Hey, it's Miss Harris, and I'm thrilled that you're tuned in to see what's happening with Miss Harris. Types of solution. In our equation unit so far, all of the problems we've solved have had exactly one solution, meaning that we were left with a variable that equaled another number. So, is it possible to have more than one solution in other types of equations? Yes, in this lesson, you're going to learn the three types of solutions for equations. So yes, it is possible for there to be a such thing as one solution, no solution, or infinitely many solutions. No solution would mean that there is no answer to the equation, meaning that it is impossible for the equation to be true no matter what value we assign to the variable. Infinite solutions would mean that any value for the variable would make the equation true. How to determine the number of solutions an equation has. Step 1. We will solve the equation using the order of solving multi-step equations, DCMAM. Step 2. We will consider the types of solutions for equations and classify accordingly. And they are as follows. One solution. One solution is when the equation ends with an isolated variable that equals a rational number. Infinitely many solutions is when the variables are eliminated, resulting in two numbers that are equal. No solution is when the variables are eliminated, resulting in two numbers that are not equal. How many solutions does this equation have? One solution, infinitely many solutions, or no solution? Here's our problem. 5 times the difference of p minus 2 equals negative 15. The first thing we're going to do is draw a line down the equal sign to balance the equation. Then we will use the steps DCMAM to help guide us in our problem solving. First, let's check for the distributive property. Can we distribute? Yes, we know that we can distribute because there are parentheses on the left side of the equal sign. Therefore, we'll multiply 5 times p, which is 5p. 5 times negative 2, which is negative 10. Since there are no parentheses on the right side, we can just bring everything else down. Now we will check for like terms. Are there like terms on the left side of the equal sign? No, we only have 5p minus 10. They're not like terms. Are there like terms on the right side of the equal sign? No, we only have the constant, negative 15, so no like terms there. We can cross out the C. Now let's check for M. Move the smaller variable. So we ask ourselves a question. Are there variables on both sides of the equal sign? No, we only see the letter P on the left side, therefore we can scratch out M. Next, let's check for constant terms. Is there a constant on the same side of the equal sign as the variable? Yes. On the left side of the equal sign, we have 5p minus 10. So we need to eliminate the minus 10 by using inverse operation. Since it is being subtracted, we will add 10 to both sides of the equal sign. This will leave us with 5p equals negative 5 plus 10 is negative 5. Now we will check for the next step, m. The last step is m, which stands for multiply or divide. Since we have 5p that represents 5 times p, the opposite is division. The opposite of multiplication is division. Therefore, we will divide both sides by 5. This will leave us with p equals negative 1. So let's answer the question. How many solutions does this equation have? This equation has one solution. Yes, it has one solution. And we know that it has one solution because negative 1 is the only one number that will make this equation 2. Our variable p can only equal negative 1 to make the equation true. Here's our next example. How many solutions does this equation have? One solution, infinitely many solutions, or no solution. Here's the problem. 9x minus 4 equals 5x plus 4 plus 4x. We'll draw the line down the equal sign to balance the equation. Then we're going to use our steps, DCMAM, to assist us in our problem solving. Let's check for the distributive property. Do we see any parentheses in this problem? No, so we can cross out D. On the left side of the equal sign, we can begin checking for like terms. No, there are no like terms on the left side. All we have is 9x minus 4. Moreover, on the right side of the equal sign, there are like terms. Our like terms here are 5x and plus 4x. If we combine those terms, we'll be left with 9x. Now that we've combined like terms, we can bring everything else down. Then we can check for m, move the smaller variables. So we ask ourselves the question, are there variables on both sides of the equal sign? And the answer is yes. We have the variable x on the left and the right side of the equal sign. Now let's see which one is smaller. Neither one of the variables are smaller because they're both the same. When they are both the same, remember our rules, we will eliminate both variables. We'll eliminate both terms. Then we'll just bring down what we have left, which is negative 4 and positive 4. But let's ask ourselves a question. Are these results equal? Are these numbers equal? Are they equal? Does negative 4 equal positive 4? And the answer is no, they are not equal. Negative 4 and positive 4 are not the same number. Therefore, our solution is no solution. No solution means that no number will make this equation true. Here's our last example. How many solutions does this equation have? One solution, infinitely many solutions, or no solution. Here's the problem. 5x plus 3 equals 2x plus 3 times the quantity of x plus 1. We'll draw the line down the equal sign to balance the equation, and we will use our DCMAM steps to guide us in our problem solving. Let's check for the distributive property. Can we distribute? Yes. There are parentheses. So we'll first multiply 3 times x, which is 3x. Then we'll multiply positive 3 times positive 1, which will leave us with positive 3. We'll bring everything else down to continue solving the problem. Now let's check for like terms. Are there like terms on the left side of the equal sign? No, all we have is 5x plus 3. Now let's check for like terms on the right side of the equal sign. Yes, there are like terms on the right side of the equal sign. They are 2x plus 3x. If we combine those terms, we'll be left with 5x. Then we'll bring everything else down to continue solving the problem. Now we'll check for m, move the smaller variable. We'll ask ourselves, are there variables or letters on both sides of the equal sign? And the answer is yes. There are variables on both sides. Both of those variables are 5x on the left and 5x on the right. With the variables on both sides are the same. Since neither one are smaller, they're both equal, we'll end up having to eliminate both terms. Now we'll bring down what we have left, which is positive 3 and positive 3. We'll ask ourselves, are the resulting numbers equal? Does positive 3 equal positive 3? Yes, positive 3 does equal positive 3. Since our variables were eliminated, resulting into numbers that are equal, then our solution is infinitely many solutions. Infinitely many solutions means that any number, any rational number will make this equation true. Now it's your turn. How many solutions does this equation have? One solution, infinitely many solutions, or no solution? I know you've got it. Let's go. Now let's check our work. For your solution, you should have gotten no solution. How did you do? Amazing! Check your work. Here's the next example. How many solutions does this equation have? There are your options. Here's the problem. Are you ready? Let's go. With this problem, your solution should have been infinitely many solutions. How did you do? Amazing! Now let's check your work. Here's our next example. How many solutions does this equation have? Again, here are your options. Here's the problem. Take your time. Let's go. All right, let's check our work. For this problem, your solution should have been one solution. How did you do? Incredible! Let's check your work. Here's our last problem. How many solutions does this equation have? There are your options. Here's the problem. Take your time. Let's go. Okay, let's check your work. For this problem, your solution should have been one solution. How did you do? Fantastic! Now let's check your work. All right, all right, all right. You all have done so well with our equations unit. How do you feel? Has your understanding of equations increased? I pray that you have done so well and that your confidence in your mathematical problem solving has improved. You persevered, you've shown up, and I'm so grateful. Thank you so much for tuning in with Happening with Miss Harris. Look forward to seeing you again. Toodles.
What we do here is go back, 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 back.